right, so hopefully you watched Mrs. Fry's video about how to get yourself situated for taking notes on your own. So anytime you need to pause the video just to write what's on the screen, definitely do that, okay? So pause as you need to. So you might want to just pause right now and write down all this stuff and then come back for a second and listen to the explanation. So pause if you need to. All right, so what is a logarithm? That's a new word for us in our Algebra 2 curriculum. It says you know that 2 to the second is equal to 4 and 2 to the third is equal to 8. However, for what value of x would 2 to the x power be equal to 6? Well, hopefully you would say it's somewhere between 2 and 3 because 6 is somewhere in between 4 and 8. Well, the way that we figure this out as a mathematician is something called a logarithm. So the value that we want is equal to the logarithm of our base, right? The base of our exponential of that number. So y is equal to the log base b of x if b to the y is equal to x. So what that means is b to the y is equal to x. There's a nice little switch around that goes on there. So here's our official definition from your textbook. So log base b of y is equal to x if and only if b to the x is equal to y. B to the x is equal to y. Okay, so that's kind of confusing. You can pause if you need to write all that down. But what you really should think of is that a logarithm is a type of exponential. It's really just something that's been rewritten. Eventually, on our next lesson, it will act as the inverse, or the thing that undoes an exponential. And if something undoes an exponential, we will be asking the question, what power? So, just like that one that said 2 to what power is equal to 6, well, log base 2 of 6 is that power. Okay, we'll talk about how to write that with some examples. So the way these are going to go, I'm going to do 2 problems and then you're going to do 2 on your own, okay? So rewrite the equation in exponential form. Exponential form means that there is something with an exponent. So right now we have something in logarithmic form because there's a log, and I want to rewrite in exponential form. So that's what we're going to do. Some people call it the recycle method. 3 to the second is equal to 9. Which is a true statement, right? 3 squared is equal to 9. This next one, 25 to the first power is equal to 25. Also a true statement. So in general, what's in the basement becomes the base of our exponential. So b to the y is equal to x. Go ahead and pause your video and write down these 2 and try them for yourself, rewriting them as exponentials. Pause your video. Okay, go ahead and check your answers against mine. 2 to the 5th is equal to 32, and 1/8 to the negative 1 is equal to 8. I just put that in parentheses so the whole fraction is raised to the negative 1. All right, so if we can rewrite from logs to exponentials, we can rewrite from exponentials to logs. So one thing to notice on these ones, and we'll talk about this more in our next video, what I really did is I rewrote a 3 to cancel that stuff out, right? Exponentials and logs are inverses, so 9 is equal to 3 squared. So here, I need to get rid of this exponential, so I'm going to take the log of both sides. I'm going to need a log with a base of 7. So log base 7 of 7 to the second is equal to log base 7 of 49. These then are going to cancel themselves out, so 2 is equal to log base 7 of 49. Again, what you're undoing this time is our base of our exponential goes in the basement of our logarithm. And you can check that by doing the little recycle method. 7 to the second is equal to 49. This one, I'm going to use a log base 3. So negative 1, right, because that's going to go away, is equal to log base 3 of 1/3. Okay, so I'm using a log base 3 because that was the basement. And then negative 1 is the thing that I was trying to get down. 1/3 is the other side. So if you start in exponential form, okay, the b from the base gets written as the base of the log. What was free over here now goes inside the log, and what was stuck over here is now free by itself. Okay, so go ahead and use that information. See if you can rewrite these ones in logarithmic form. So we should have a log in our final answer. Pause your video and try to do those. Okay, so if you look, I chose my base for my logarithm to be 16. 3/4 was stuck, now it's free. 8 was free, now it's stuck. I chose 7 to be the base of my logarithm. Negative 3 was stuck, now it's free. 1/343 was free, and now it's stuck inside of the logarithm. Okay, so this is just rewriting, and we're going to use this rewriting as we get further into our work with exponentials and logarithms and how they relate with one another. So right now, we just want you to be fluent in kind of going back and forth. It's almost like translating a language, right? So if I give you something in English, you should be able to read it in French. If I give you something in French, you should be able to translate it back to English. That's kind of what's going on here. Okay, so evaluating the logarithm is where we want to use that question about power. So superpowers, what power is our question that we're going to be asking. Remember, you can pause your video anytime you need to write stuff down in your notes. But evaluate the logarithm. We need to find a value. So our final answer will be a number, not an equation like we just had. And so this is saying 2 to what power is equal to 64. Now, if you have your power book from our last unit, you can use that. 2 to what power is 64? That's going to be 2 to the 6th power. So log base 2 of 64 is 6. This next one, we're going to ask ourselves 9. 9 to what power is equal to 81? Well, hopefully you remember from your power book that 9 to the 2nd is equal to 81. So log base 9 of 81 is just 2. I'm going to help you get set up on the next ones, and then I'm going to have you pause to try for yourself. So this is going to say 8 to what power gives us 2. And this one is going to say 3 to what power gives us 1/27th. See if you can think about those for a second. Pause your video, write some stuff down, do a little bit of thinking, and then we'll reconvene. Pause your video. All right, well, I know that 2 to the 3 is 8, so 8 to the 1/3 will be 2. This one, I'm going to say 3 to some power is 1/27. Well, I know 3 to the positive 3 is 27. So 3 to the, I made a mistake. 3 to the negative 3, we'll flip that to the bottom. Now, the other thing is we can use our calculator for these. So go ahead and grab your calculator if you don't have it nearby yet. And most of you, if you have the newer calculators, will have a math button. And if you scroll up, you can change the log base. Not everybody will have this, so you might have to use Desmos or use an online calculator, and that's okay because we're doing our e-learning. But if you look, I can type log base 8 of 2 is equal to 0.33333333. If I'm not sure about that fraction, I can go that way. Again, math, log base. So log base 3 of 1/27th is -3. Okay, so you can use your calculator to evaluate logarithms as well. And again, if you don't have that button, just jump online, use the Desmos calculator to do it. That'll be totally fine for the time being. And we will learn eventually a way to do it on your calculator, but you can also just ask yourself that whole what power question is a great way to go. All right, this next one, I do want you to pause your video to write down this box of information. This is one of those important dash boxes that you'll definitely want to have on your summary sheet. So take a second to pause and write this down, and then we're going to talk through what each one of these things is. Okay, so log base b here, b is just going to stand for any base. So this could be base 2, base 3, base 5, base 10, base 2017, don't know. Okay, so log base b of 1 is always going to be 0. Because if we do our little switch around, that would mean b to the 0 power is equal to 1, which is always a true statement. This next one, log base b of b, so this might be like log base 2 of 2, log base 10 of 10, log base 4 of 4, log base 8 of 8. That's always going to be equal to 1. Because, again, if we do our rewrite, that would say b to the first power is equal to b, which is always a true statement. These next two deal with the fact that logs and exponentials are going to act as inverses. So log base b of b to the x power, these are going to cancel the bases because they match, and we're left with just x. Okay, so log base b of b to the x is just x. This one is written as the inverse. B as the base of an exponential raised to a log with that same base, those now are going to cancel each other out as inverses, and we're left with just x. This last one to think about, if log base b of x is equal to log base b of y, then whatever's inside the argument, okay, whatever inside the logarithm, whatever's trapped, those will be equal to each other. So then x is equal to y. What that looks like is if I had something like log base 2 of 7 equals log base 2 of x. Well, log base 2 of 7 is the same structure as log base 2 of x. So the log 2 and the log 2 are the same, which means that the 7 has to be equal to x. Okay? So that was our first intro into logarithms. Here I am on a log flume. Please make sure that you try the assignment and big ideas. There's also an extra practice worksheet that's posted. And of course, please send an email to all of your Algebra 2 teachers. One of us will be able to jump on and help you with any questions that you have. Logarithms is a big unit to be switching to, and it will be a little bit of a challenge to switch while we're doing e-learning, but we believe in you guys and we are here if you need us. So please, please, please ask us questions. We miss you. Bye.